All right, good morning, everyone. We're going to have our weekly storage API sync. Today, we're mainly going to talk about the Kusama relayer that Serge has been working on. So, Serge, if you want to take it away and update us on the status on that project, please.
Sure. Let me share my screen. All right, let me show you what were pull requests merged due since we last spoke. So the biggest one was multiple accounts, and I think last Thursday we also spoke about this, but it was in progress. So let me just give you a quick overview. Yeah, this is a minor change that converted ESLint config from JS file to JSON. And I converted config. So previously it was a function that was returning an object, and now it's a class. So basically everything else is the same. Yeah, so now we instantiate it like this. And yeah, I renamed the field in config. So previously it was source chain URLs, but in fact we have like an array of objects. So I renamed it to source chains. Yeah, and in this PR we introduced individual signers for each chain. So here you can see we have a master account, and from master account, so we're using same seed here from config. And for the source chain, which is in this case Kusama, we derive an account using derivation path. So in this case, we provide just chain name. And we also create, we derive accounts for parachains here, and here we provide para ID. And yeah, currently we have to fund those accounts, so we send them 1.5 units. And yeah, this I already mentioned before. We create a parachains map, and I will show you implementation. I think it hasn't changed since we last spoke. So this is a minor change. So previously, when we saw logs, there was some extra information we didn't need, like host name and stuff. So I removed it for now. And in the parachain class, we have added signer. So every time we send a transaction related to parachain, we sign this signer signs transactions. And we also do some additional validation for the results from a fetch parablock request. And we also added timeout, 8 seconds. And in source class, we have also an added signer. And
Serge, a quick question on the timeouts. Is that blocking, right, or can those get out of order if one fetch parablock is faster than the one after it?
It's not blocking. No, we just process them as they come. There is no blocking.
Yeah. So if we had like a delay on block 10 and then block 11 was requested and returned before block 10 came in, we could write them to the chain out of order.
Could you repeat again? So we have
a
block. Yeah.
So if we request block, like we get Kusama block 10 and we request corresponding Akala block, and the Akala block takes 8 seconds, longer. But then 2 seconds later we get another Kusama block and we request the next Akala block, and that comes instantaneously. Can we write Akala block 11 to the feed before we receive Akala block 12, and then write 12? Or sorry, can we write Akala block 12 to the feed before we get block 11, and then once we get block 11, we write 11, so they get out of order?
I think I understand. Yeah. So Currently, we merge all these streams of blocks together. So when one block is ready, we process it. So if it's not yet ready, then we move to another one. So we do not maintain order.
Okay. So that's probably a to-do then, that we need to figure out how to maintain the sequence, the pair of blocks as their height appears.
Okay.
It's not a critical to-do. I mean, that's like that's fully robust, but that's something that we're going to have to take care of eventually.
There is another
Okay.
problem with the timeout. I think it's timeout on the stream or something instead of timeout on the request itself. So you may end up in a situation where you have multiple requests in the background which are just hanging, and you will never read them. So you probably need to specify timeout in the init object for the fetch API.
No, I think it's a timeout for the, because this method returns an observable.
Right, but
So
internally it uses fetch. The fetch is not aborted.
Internally, yes.
So you either need to create abortable and abort it or do something about it. Otherwise it will just be in the memory leaking.
I will check it, but I think this works as it was intended.
It doesn't do anything about the fetch API.
Okay, I will double check. Anything else on this?
No, that's it. Thanks.
Okay. And in the source class, yeah, so we fetch parablocks, and so previously there was a problem because we were handling blocks, parablocks and relay chain blocks. We were sending them as a stringified JSON right here, but because we fetch relay blocks from the Polkadot API and it returns an instance of a signed block class, which has method to string, and it converts it to the nice stringified JSON. While parablocks, we get them from the HTTP endpoint, RPC API endpoint, and those are just JSON files. And if we call to string on a JSON, it will just be object. And that was an issue why we had like 16 bytes size for parablocks on Relay UI. So this was fixed here. So now we just stringify JSON for parablocks, and it's same as before on relay chain blocks. Target class. Yeah, so previously we were waiting for, after sending transaction, we were unsubscribing after second status, and we assume that second status is in block. And now we explicitly check if it is in block status. So, because potentially that might change, and if we just take second, there is no like guarantee that this status is actually in block status. So now we explicitly check. And we also have some.
What is second status?
So first status is like sent or something, and second status is in block for extrinsic.
So it's like a state machine for the parablocks.
Right. Yes.
Okay.
So previously we just calculated first, second, and now we check explicitly status in block is in block. So if it's true, then we unsubscribe and we don't really care about it anymore. And we have added a catch error just in case something fails here. Not just here, for every, yeah, we do it for every transaction method. And yeah, this is a new method to send balances. Yeah, so we have from, to, and yeah, just a simple transfer. Yeah, and we resolve when status is in block.
This is to plus up the proxy accounts or the secondary accounts in case they need additional funds.
Yes,
okay.
Yes. Okay, so some minor changes here. So block number in metadata before was a string, now it's a big number. Yeah, this was previously in the config. I moved it to types module because we use it in the utils right here, where we create this parachains map. So yeah, we loop over parachains in config, and we add a signer to each one of those, and we create a feed for every parachain. We instantiate a parachain class, and we save it to the map and return the map. So I was trying to do it using for each, so it will be like done in parallel, because we have now we have individual signer for every transaction, but it still doesn't work as expected. So yeah, I have added to do to investigate. And yeah, this is a little helper function to check if block is valid. So basically, if it has property block, header, and extrinsics.
I think it should have been map, and then you do promise await, promise all, and await.
Yeah, I tried that too, but still doesn't work. I think I will just use RxJS API for this. Yeah, that's it for this PR. Any questions on this?
This has already been merged in, right?
Yes, all of the PRs I'm showing are already merged.
Great. Looks good to me. Thank you.
Let's jump to the next one. So this one is relatively small. So previously, if there was a new parachain on Kusama, and the relayer didn't have this parachain in config, it was crashing. And now we just, yeah, so previously we were throwing an error. And now instead of throwing an error, we log error. So we will have something in the log that there is an unknown para ID. But yeah, we just return an empty in the observable, so it doesn't crash. We can keep processing the rest of the parachains. And I also added some debug logging here. Yeah, this one is small. Any questions on this?
Looks good.
Okay. So the next one is also like a small optimization. So previously, when every time we start relayer, we had to send this create feed transactions every time. And now we have, I created this feeds JSON, which is an object. And we use it as a dictionary. Every time we create a feed, we save. So wallet address is a key and the value is a feed ID. So next time, if we restart relayer and we check in this dictionary if there is already a feed ID for this particular signer. And yeah, I have added a new parachain, which is parallel Heiko. And yeah, here I added try catch because, well, there are a lot of things that can fail potentially. And here, so for example, for a source chain, Kusama chain, previously here we were sending create feed transaction. So now we are calling this get feed ID method, and I will show you how it works below. And yeah, here it is. So yeah, it accepts a signer, and we check this feeds JSON file. We read it, parse it as JSON, and we check if there is an entry for this address. And if there is one, we create an instance of US64 and return it. And if not, we send transaction just as we did before, and we save it to this dictionary. And yeah, we write a new feeds JSON file and return feed ID.
I think you need to check on the actual blockchain whether that feed ID exists. Because imagine you restart the chain, it might not exist, but it will think it is.
That is another problem, but we don't store this mapping like address and feed ID. We only have like feeds hash map. So we only can check if there is this feed ID, but
right. But that is better than not knowing that, because you can try to store something for the feed ID which doesn't exist. So it will error.
Okay, I can have that.
Would that also be something that if we extend the metadata for the feeds a little bit, that we could include that kind of information for a check?
We can include anything in the metadata because it's arbitrary.
Okay.
And yeah, the previous method utility function for creating parachains map, instead of sending transaction, we're using this method as well. Any other questions on this PR?
Nope. That's good.
Okay, and this one I think I also mentioned last time, but let's just give it a quick overview. So we have added totals for in the palette feeds, so we can show it on the front end. So we have a new hash map totals, and we store for every feed ID, we store this struct with total size and total number of objects. And yeah, every time we put something, we update this value in the hash map. Basically, we add the object size to the total, and we increment number of objects. And we also updated the event. We also provide now object size. And when we create feed, we basically insert, create new entry with this feed ID in this hash map. Any questions?
Quick question or quick thought comment here, I guess. Nazar's working on adding the object mappings into the archiver right now, so that as these objects are produced, we get their IDs, and we add that to the index that the farmer stores, so that they can retrieve these objects if they're requested over the network. I'm wondering if it would make sense if we compute the object ID, which is just the hash of the object, right? If we compute the object ID either on the client or here, and just go ahead and cache the latest object ID for the feed in here, or if that's a waste of time. Just curious what you guys think.
Why? What is the use case?
Just so you can know, like, that how to retrieve the head of the feed, just from the on-chain data. Because if you have the head, you could potentially just read it backwards from there? Because it's always like last block hash, like in a blockchain setting.
It's 32 bytes for every record, and not all data are actually like a feed. They can be just different things. Like,
well, just for feeds. I mean, not for any object.
I don't know. Maybe.
Okay, maybe something to discuss at the offsite. Just a thought I had. Any thoughts on that, Serge?
No, I'm afraid.
Okay. Okay, looks good.
Yeah, so these are OPRs I can show you. Demo you have seen yesterday. And yeah, today I was working on actually submitting blocks, parablocks as hacks. And yeah, I made some progress. So if this is, as you can see, this is so I tried this with Kusama blocks. I created a function to craft basically hacks from JSON, and I compare it to the original result from toHacks method on the block. And yeah, it's almost the same. The only difference is this prefix for extrinsics. I know it's like it's a compact number.
Yeah, it's scale codec length. I can actually show you how it's implemented.
Yeah, so that would be very helpful because this is the only thing that left. Everything
I was
else
reading
is...
that code today because I was doing these mappings. So I just went through all of it.
Yeah, so after this, I hope we will be able to send hex instead of stringified JSONs.
What's the optimization that we're getting there? It looks like we're just removing like a little bit.
Well, hex is much smaller than JSON.
Okay.
It will essentially store binary block
Yeah.
instead of JSON. So you can pull the binary block, you can just send it through decoder, it will decode into native type in Rust, for instance, or
Yeah,
in JavaScript.
I can actually show you. So this is hex. It's not very like nice and readable, but and this is a JSON. So we can see it's much bigger.
Okay. They both look pretty unreadable to me, to be honest, but I guess if you look at this stuff all day, it looks different.
Yeah, those are encoded stuff, yeah.
Okay.
Yeah, I guess that's it on my side. Yeah, I also did some like research and exploration. I mentioned yesterday, like free transactions, and do we still need custom types to get this to connect to other RPC APIs, and do we still need it? And yeah, but zero fee transactions are actually possible. Those accounts don't even need a deposit, existential deposit. It works just fine.
Okay. So so Serge and I had a call yesterday or the day before. We talked for a little while about a specific plan for the relayer for the next steps. So I think, Serge, it would be useful if we just reviewed that with the rest of the team really quickly, and then we could talk about like looking at the board, kind of about the plan going forward for that, and what the estimates are in that.
Yeah, let me show you the board.
Do you want to do the diagram first, or I can do the diagram if you want from Lucidchart?
Yeah, let's do diagram first.
Okay. You guys see this?
Yeah.
Okay, so the big change we're trying to get is that we're trying to back up the previous history of these parachains in the relay chain, not just the history from the point which we start up the Relayer app. So the basic idea that we've got here, and this is just an example for Kusama, is that we've got some server that we're running. There's a Subspace node running on that server, and we're going to have some sort of a script or a process which is going to go out over the network, talk to some Kusama node or some Kusama RPC, and it's just going to retrieve the full block history, like the full archival history of Kusama or whichever chain we're talking about, and then just write that to disk. So there's basically going to be like a folder, which is Kusama, and then a bunch of files, which would be like 1, 2, 3, 4, whatever the block numbers, and then the file would just be the full binary, like what Serge was just showing us of the block itself. And so the idea is that we sort of pre-archive all of this stuff locally. Now, obviously, we could do this on demand every time we spin up the node, but now we're sort of limited by the network, and we're going to be doing this many times, like restarting these nodes over and over again. So it seems like it's going to make sense, especially for testing, if we can just do this once and then just periodically update this block store. But yeah, this is like undoubtedly a very centralized approach, but this is just to get things started and be able to test and iterate faster. So the first thing here is basically to create this local block store. So all these Kusama blocks. Then we're going to spin up a new Subspace node from Genesis, and then we're going to do, at Genesis we create this, 10 megabytes or something of deterministic history, the seed data, and then from there we've got enough to start the network, to bootstrap the farmer. And now we want to start uploading the data of Kusama. So the idea is that we take a bunch of Kusama blocks, like maybe 10, 100, 1,000, we're not sure. This is something Serge is going to experiment with. We're just going to batch a bunch of these blocks. We're going to have a new transaction, a new put transaction called put many. So right now, the put transaction just allows you to put a single object to a feed. So now we're going to be able to put an array or a series of objects into a feed, under the assumption that those objects are ordered correctly as the way that they would append the feed, and do that in a single transaction. So effectively, every Subspace block, we have a batch of Kusama blocks which are wrapped in a Subspace transaction. And the idea is that we can have, at least per Subspace block, we can have one transaction for each feed. Okay, so initially we're going to start this out with Kusama block, but eventually we'll have, a Kusama block plus all the para blocks. So here would be like Moon River, its own transaction, and so on. So we might have like 12 transactions or 15 transactions per Subspace block. And we're trying to do this in an accelerated fashion. So that means that we're going to be, first off, we're doing, batched uploading. The second thing is we're going to be doing a accelerated block time as well. We were exploring some different ideas for that. It's something we need to talk about a little bit. But we need to basically, it's like some of the do-outs here, or some of the research Serge was doing, was like, well, can we make these transactions free? And the answer is yes, we can. We can have these zero-cost transactions. And if this is the only node on the network, we have no network delay here. We have no problem, no concerns about ordering of transactions, because it's the only node, and there's really no prioritization either. So it doesn't matter that it's zero cost. The bigger question is like, well, how big can a transaction be, and how big can a block be? So we need to figure that out. But then we also have this question of like, well, what the block time is. Currently, the block time is 6 seconds. So this would take a long time. At a 6-second block time, this could take days to upload Kusama. So we want to upload it faster. So we need to have a faster block time. Well, the easy way to have a faster block time is to have a smaller plot, but then we will have the difficulty resets will kick in every 2016 blocks. So if we had like a 1 megabyte block, that means we'd only get about 2 gigabytes of data in before the block reset. If, like, say we started with 100 millisecond block time, well, the block resets can only increase by factor 4. That's a security feature. So that means we'd go from 100 millisecond blocks to 400 millisecond blocks to 1600 millisecond blocks, and then, eventually, pretty quickly, we're going to get to 6-second blocks again. So we were thinking about some way, maybe there's some way that we can change the block time in the runtime, because that's something which is in the runtime palette, or the config, I guess. Versus because we do eventually want to go back to a 6-second block time, but we'd like to have this this early phase of the network where we can have this accelerated block production. So this is kind of what Serge is going to be working on over the next several days, and hopefully we'll have an initial version of this working before the offsite. And effectively, like we said before, we'll do this initial uploading. And then from that point on, every time this node restarts, it'll just check the height of all these chains and compare that, like over the RPC, it'll say, okay, what's the current height of Kusama? And then it'll look and say, well, on chain, in the feed ID, it says it was, 10,000, but it's now 10,100. So I need to go fetch the last 100 blocks, do some batched uploading, and then I'm just going to listen from there and upload new blocks as they come in. We're trying to get this working for Kusama to start. And then once we once Serge has got this pattern working for Kusama, then we're going to extend it to work with the parachains as well. It should be fairly extensible by that point. So this is kind of the plan that Serge and I came up with, and he has got all of this captured in the board as well, and has started doing some initial research on these tasks. Are there any questions or concerns with any of this?
I have one comment. When there will be this process of creating a folder with all of the blocks, just make sure to have hierarchical structure to it, in a sense that don't store all of the blocks in a flat structure in one folder, because file manager or anything you will try to use on it will just die. It's not a good idea to have like 500,000 files in the same folder, like split it into individual digits and then make hierarchical structure. And I have a question, like this put many transaction. Will it be put many, or can we use the batching functionality which is built in? What is the difference between those?
It's a good question. I think actually I didn't realize that, but yeah, we could just do multiple calls to put in the same transaction, right, Serge?
Those are like different transactions, but you can like combine them into a batch.
Yeah, but there's so I think the problem is how much data we can put in one transaction. And
Well, I think it's either
in
way
case,
the same.
so currently we are putting single object, right? Single block. But with put many, we were like planning to put like 100, or maybe depends how much we can put. So if we do batch of transactions, like instead of putting 100 blocks, we do 100 transactions, I think it will be more expensive. But I'm not sure. We have
you
to
will
measure.
have multiple signatures.
Yeah, I think
maybe it's actually, maybe it's not. We'll have to check. Maybe they foresee this thing and they have like outer signature instead of signature on everything.
we can measure.
Yeah. Okay.
So are we isn't there like with a single transaction you can do multiple calls, or does it have to be one call per transaction?
One call.
Because like in Ethereum, you can do multiple calls per transaction, right?
Yeah, because you can put a lot of stuff in the data field in transaction on Ethereum, but in Polkadot you have only like extrinsic, which like updates only one particular piece, as far as I know.
I would be surprised if there wasn't some way to do multiple calls in a single transaction.
As I mentioned, there is a batch thing. I don't know how it works, but it does what we need to do, I think.
Well,
basically like an outer extrinsic, and it has multiple intrinsics within it.
That's a different thing. That's like a bunch of transactions that are put together in a bundle. But I'm talking about like multiple calls. Like, you know, in like DeFi, you can do something like take out a flash loan, like do a Uniswap trade, and then like send it to some account. And you can basically say like, you know, call this function, call this function, call this function, like in the same transaction with like a single signature. So it's not really like batch transactions. It's just one transaction that does multiple things. So I'm saying we could
from the
just
smart contract though. It's not like from a transaction. It's from a smart contract. And
well,
in
but it's
Substrate, calls are essentially extrinsics. That's like their terminology.
Calls are extrinsics.
They call it that way.
Well, I mean, a call is an extrinsic makes a call, but it's to.
In their terminology, they have like every palette that has extrinsics, it has this enum called call.
Right.
And every like variant is a different extrinsic that this palette provides.
Yeah.
So these are like the calls in Substrate terminology. They're not like function calls.
Okay. So you're saying it's impossible. Sorry, go ahead.
Yeah, I was saying that we can experiment with batch of transactions, but from what I understood, it's just a sequence, and you can save some fees, but essentially it's like same as sending multiple transactions.
Okay. Yeah,
but
it seems like
worth trying.
Yeah, I think it would be better if we could batch it than having to write another call, like another runtime call to do a batched put. Like Nazar saying, that makes more sense to probably experiment with that first. Whether that's whichever way we can do that in Substrate framework. I'm just really surprised. It seems like that would be such a basic use case that they would support, you know, to be able to do these like sequential calls within the same transaction. Okay, any other comments on this?
Yeah, I got a question about what happened when a new parachain is added. What's happened with the history of that parachain, like after it's everything running?
It doesn't support that use case right now, bottom line. So whatever, I mean, probably something where it would be like, we have to manually add a new parachain, and then it would have to just like, either we would build this local block store and preload it, or it would have to go and like fetch over the network, fetch the transaction or fetch the blocks, batch upload up to the point. I mean, basically it should start at 0 and catch up and then just as normal. But it doesn't support that yet. This is not the end product at all. This is just trying to get Kusama first, then the existing parachains, and then new parachains we'll need to figure out for sure.
Okay.
It's a good question, but it's we're trying to do it in baby steps right now. Is that kind of how you thought it would work, Serge?
Well, I can't say I understand how it should work. I'm still in progress of understanding the whole picture.
Okay.
And I think this will change in the process.
Of course. Okay. Nazar, do you have any thoughts on how we can handle this block production time challenge here?
I haven't tried to actually modify it on the fly, but the worst case, I think we can just do runtime upgrade. That should be supported. So we can just upload everything we want and then do runtime upgrade, and it will change the block time.
Okay. And if we're plotting, the other concern here is if we're uploading this massive amount of data and we're also plotting that data, is that going to create some sort of a like blocking or like issue? If we're, do you see what I'm saying? Like, because the farmer might get like overloaded here because we're just uploading data way faster than it's expected. And then also that plot will be increasing, which will also change the block time. Even if we have like, even if we reset the block time to be 100 milliseconds, if the plot is growing, it's going from like 10 megabytes to 1 terabyte, then, well, I guess the solution range should update itself. It just feels like it's going to be really like all over the place with the block production time. So it's almost like we need to even turn off, like in this setting, we should like set the, you know, basically just set like a constant block production time, like not even have a dynamic difficulty anymore. And maybe somehow, I don't know if there's a way we could do this without having a farmer, or with having like, maybe the farmer could have like a no pruning mode or no continuous update mode, where it's just, or maybe it does it like in the background or something. Do you see what I'm saying there?
It will actually not accelerate infinitely because we will still have slot time. So it will not produce more than 1 block per second if you have 1 second slot time. So even though the plot size will increase and difficulty will be too little for the plot size, it will not like infinitely accelerate and like consume all of the resources. So I think it should be fine.
Okay, that's true. It can't go below the actual challenge slot time. That makes sense. Okay. And you don't think that plotting is going to like somehow there's not going to be like a queue that'll get overloaded with the archiver?
There is no queue. It will just be it will lag behind the latest head of the chain. So it can be like 100 blocks behind, 1,000 blocks behind, but once block production normalizes, it will catch up. Since we have the full archival node at the moment, it shouldn't be a problem to retrieve older blocks.
Okay, so basically the farmer like takes the blocks one at a time over the RPC to the client,
more or less,
and then archives them, and then once it's done, it goes and gets the next one. So since the client is writing these to disk, that won't be a problem. Okay. So that'll change once we have a different notion of a client, but okay, that's good to know. Okay, so I guess from your point of view, Serge, when you're working with this, you should have a branch of the node or of the client, which has a runtime of like 100 milliseconds or something like that, hard-coded into it.
If 1 second is acceptable for this use case, then you don't need to do anything, because your plot will grow so fast, so big that it will naturally pin itself to the slot time.
1 second is probably going to be too slow.
Okay.
But I guess we can experiment and see. I think even 100 mil, I mean, it could be the difference between like 1 hour and 10 hours, or 1 day and 10 days, something like that. Because I think it's looking like this data for all of the parachains is going to be somewhere around 1 to 1.5 terabytes, which means that the farmer plot is going to be like 2 to 3 terabytes. Okay. All right, I'll stop sharing. And Serge, if you want to go back to the board and we can talk about the implementation of this.
Okay, so yeah, this is what we have added. Relayer startup checks, skip power blocks. So this is already done. Should we just walk through first and then update, or we can update right now?
We can update it right now. That's fine.
Okay, so this one is in progress because I have only added checks for feed IDs, but we also need a last process block and skip para blocks. This is already okay. So this is a new one. 0 weight. This was a research, and it's done.
So we can have 0 weight puts, or we just or 0 transactions.
Yes, we can.
Okay. Is it, and has that been implemented for put as well?
Not yet. It was just proof of concept.
Okay, so that's probably something that we need to add to the board then, to change the put to be free, or to create a new put call which is free, which we can only call like maybe in some initial stage.
Okay. Yeah, so this is something that was mentioned on the diagram. We need some kind of block size limit on the target chain, and yeah, we can try 1 megabyte for now. So restart. So yeah, this is
Serge, sorry to interrupt. On that note, Nazar, have you been able to look and see if there's any transaction size, block size limits? Has that appeared anywhere in your research on Substrate?
I didn't see it, but I believe it's just limited by the weight. So if you make the weight derived from the size, we will be able to limit it.
Okay, so it's like Ethereum where there's like a max block weight.
That's my understanding. I might be wrong.
Is that somewhere in like the runtime constants to define that, or is that like hard coded into Substrate itself?
On every extrinsic, you have a way to specify weight. It can be fixed. It can be like a call to a function that can do some computation based on.
No, I get that. I mean, but is there a way to specify for the block what is the maximum weight of all the transactions or all the extrinsics
Yes.
in the block?
I think it's 10 million units by default, or 10 billion, something like that. Basically, 1 unit. Okay, so it's not size. It's actually like computation. I think 1 unit is 1 nanosecond or something, and you specify how much computation you want to do.
Is that in the
maybe there is no limit on the data size.
Is that in the runtime itself? Runtime constants?
Yes, I think so.
Okay. So if we have 0 weight put calls, then effectively it doesn't matter what the weight is.
Yes.
Okay. So then it's basically just internal to the relayer. We would define some.
But that's like not recommended because you can overload the consensus. You can cause all kinds of problems. So it should be something. Yeah, this needs some research.
Yeah. So I think we should just, like, inside the relayer itself, we should just define some notion of how many transactions we're going to submit for a block, to make something like if it's 1 megabyte max transaction and we have 12 feeds, and that means that we have 12 megabyte max block size effectively, which is probably okay for this setting. We'll just have to experiment with it. Okay. Do you want to keep going, Serge?
Yeah. So this one is so basically, if we stop relayer, we have to remember what was the last block processed, and if we restart it again, then we start processing blocks from the last process block, not just new blocks that we get from subscriptions. Yeah, and This one is pretty straightforward. Since we are processing Kusama blocks from Genesis, we have to store it in the file system. And yeah, this one is also straightforward. And then after we store them on the file system, we need to process them from the file system instead of getting new blocks from the API. And then we extend this. So we first do it for Kusama, and then we extend it for parachains. And that's it.
Okay, and what are the immediate next steps you're going to be working on, Serge?
I was planning on starting to work on saving Kusama blocks in the file system.
Okay.
So first we finish this hex block submission, and then yeah, saving blocks to the file system.
Okay. And then with that hex issue, we're not going to be able to do that for the parachains unless they're up to metadata 14, which several of them are not. So we're still going to need custom types for them to really have an efficient storage of their blocks.
No. So currently I'm working on actually saving parachain blocks as hex. Because Kusama blocks, we can do it just calling toHex method right away.
Okay.
But because Kusama blocks, we get them as JSON files, so we need to do it, encode them manually.
Got it. So this is going to make it so we can have efficient storage for all the parachains.
Yeah.
Got it.
And then if everyone updates to metadata 14, then we can get rid of it. It's like a temporary workaround.
Well, by then they'll have metadata 15, and we'll probably have to have some hack for that.
Yeah.
Okay. Cool. Well, that looks really good. So yeah, looking forward to seeing your progress on that, Serge. Any questions from the group on any of that?
I just wrote down a few notes as you were talking, and I was just wondering if Serge could keep the board on the screen. I just want to know if any of these need to be added to the board or if they're accounted for. Is that cool?
Yeah, one sec.
I just I wrote these down, but you guys understand the context, far better than I do. So there was a note there about figuring out how to maintain the sequence of parablocks as their height appears. You mentioned this wasn't critical, but we'll need to take care of it at some point. So do you want that on the board?
Yeah, definitely. Great catch, Courtney.
Serge, can you add these? Yeah, perfect.
I'm adding.
Okay. The next one was, this seems small, but Nazar and Serge had a discussion about the use of that timeout function. I don't really understand that conversation, but does that need to be captured on the board? Okay. There was a discussion on batching versus the put many, and the takeaway I think was that Serge had to go and experiment there with the batching feature or functionality. So I just, again,
yeah, we've got put many on here already, so I think that's probably covered.
Yeah.
Okay. I think Leo brought up getting the history of new parachains. Does that need a place on this board in the backlog?
Yeah, it's probably not a bad idea to include that. It's kind of,
No, I
or is
think
that captured?
this is extending processing for parachains, no?
Well, that was just to the existing parachains, or at least that's how I had it in my mind, versus like being able to dynamically support new parachains. Seems like there was a ticket for that on here somewhere about support of new parachains.
There was this one, dynamically get Kusama parachain, but this is not exactly the history of parachains. This is just
that was for the front end config, right?
No, this was for the backend, for the relayer, and there was I think there was another one from the front end.
Okay.
So, okay, new purchase history.
Okay, and my final note was, Serge, you did research on zero weight put call, but do you need another ticket for actually implementing it? Or is that
Okay.
covered?
This one.
Okay. All right, those are all the notes I had.
And we also, there was a comment from Nazar on checking if feed ID exists on the palette. I think it's here. Anything else?
Not from me.
Thanks, Courtney.
Okay. Any other comments on your side, on your work, Serge, or questions for the group? Questions for me and Nazar?
Yeah, maybe we can sync up with Nazar later regarding this prefix I'm currently working on, so I can finish it and jump to the next one.
Which prefix are you talking about?
The prefix for scale encoding.
Oh, right. Okay.
This compact, yeah.
Okay,
Yeah.
awesome. Leo, do you have any updates you want to give on the relay or front end? Is there anything that's changed since Tuesday that you want to go over with that?
No, I just added all the backlog tags for the future, actually. Maybe I can share my screen.
Sure.
I also have a question about this board. So there's a lot of stuff in backlog, which Leo did, but then there's also stuff in the no status column. Is that the same? Like they're all just backlog, right?
Previously, I only had one column, so now we have two columns. I don't really know why.
Okay, I think they're all the same. So like, I'm just gonna drag everything in no status into backlog. Because I think we just added backlog last week, that's why.
I think there is a difference in terms of sort of what's like, there's a priority difference there. So, and I think that there might actually be, just reading through them really quickly. I think some of these are like way backlog, and some of these are just like not immediate priorities, but next steps after immediate priorities are done.
I see.
But we already
makes
have
sense.
not started column. So I think we need to remove no status and just move either into backlog or to not started.
Yeah. Maybe the goal there was just to keep it readable within one view instead of having like an infinitely scrolling board. But
I mean, you could have no status could be like a staging column, because like the not started column means that the team has agreed that this needs to be done now. Like this is on the schedule to be done. And then backlog could be way out in the past, as Jeremiah said, and then you may want that middle like staging column for like, we're not ready to have people work on this, but we know it's coming up.
yeah, I think staging is a good word for it. But it's not really clean. Like there's some stuff that's in backlog should actually be in staging. So we probably need to spend a little bit of time reviewing that. Okay, let's let Leo give his updates and then we can review that more.
Oh, I added all these backlog tags actually, but I have closed it. Actually, I didn't move it. I'm waiting for this call, but I already done this task from here. I think that I will move to complete it. This one.
Has that PR been merged?
Is this one actually? Is the last one? I have merged the first PR, and I have two pending PRs in these ones. Actually, Serge have reviewed it, and this one that is the final version with all the commits actually. Just to comment that I have updated a little this with the latest new parachain added actually, this parallel Heiko, and that's the final commit actually, the last commit. So I'm gonna review this and finalize this merge, and it's just that. And I already implemented all your feedback actually, and a couple of Diana feedbacks, and that's completed too.
What was that feedback, Leo?
All the things that you sent me from Discord, it was in there actually. It's in here, in the resolved comments, all this feedback from here.
Okay. So is that what you showed yesterday, or is there new stuff since then?
Just a few changes in visual terms actually. Changed the font size and a couple of things. Yeah.
Was that feedback from Diana?
Yeah, we had a call yesterday, and she showed me how to export a lot of things from Figma, and I added a couple of styles in there from design system actually.
It'd be great if you could just review that in a little bit more detail with us, like what's been changed there, just so we're all on the same page.
I think that it was actually the colors. It was kind of different, and I added the Montserrat font size for the headers, and just that. Yeah, I think.
Do you want to just pull up the PR for that, and just, you don't have to walk us through every single line of code, but just at least the commits, and show us what changed?
I got it open it actually in here, and yeah.
Can you make that a little bigger? Like or increase the font size a little bit, please?
There is, and I think that the last changes are in here. In terms of, I added this top level README with all the instruction to run and how to run the node actually, the relayer, and I changed this to run with npm, and how to build locally and serve locally, and how to build the CSS also locally. And I edited in here a couple of things in in terms of tags. I was using it in here Spartan before, so I updated to Subspace. And finally, I followed this change that Serge suggested me to change moment for date FNS, and it was actually pretty cool. It was like a tiny code, and I fixed some kinds in the footer, some missing spaces in the footer text, and yeah, I think that the other things are from the PR itself, and other changes are in here. Actually, I removed this. I changed these headers for spans. Actually, it was using H2 and H3 in all the spans, and I removed a couple because when you used this H2 or H3 tag, you were in like receiving the font from other configuration. So I changed this to be able to show it as Montserrat in the CSS. And yeah, I think that's everything because the other changes are in here in the parsing row. I made these changes in the span actually. Also, I removed the tags to be showed as normal text and not as headers actually. And the same in the parsing table actually. Yeah, I removed a couple of tags in there. With these changes that you made, Serge, about the how you were sending the parsing object, it's allowed me to delete a couple of hard-coded things that I have in there. So as everyone has the same format, I now can just do this for each without a validation in there if it was Kusama or parachain actually. And yeah, the other things are just kind of styles. I changed these two, and I added this. I changed these available parachains. Actually, I created a chain name property to have it more clear actually, and basically to avoid make some parsing in the code itself. With the chain actually. I was using the change and change it to capitalize, and I decided just to change that and have it separately. Yeah, in the other things are chain props and for the interface of the chain configuration, the parachain configurations. And I updated this main layout just to load the main components in here. Yeah, I think it's just that. Yeah, that's the final commit, the latest status.
Awesome. Could you show us, just like spin up the node really quick and show us what it looks like now, how it's changed, or the app?
I don't have it running actually. Yeah, I don't have
Okay.
because I have to load all the. Oh, maybe I can do it fast.
If you just, if it's going to take you a while, if you just would like to share a screenshot of that, and I'd like you to be able to show that at the all hands as well tomorrow, if you can have that set up. Actually, just for the group, I'd like everything that we showed at the builders lightning demos. I'd like to show to the business team at the all hands tomorrow. So because I think they have like a really abstract notion of like what you guys are doing, and showing them like what you guys are building will help them understand it a lot better. So we don't have to do that right now, Leo. We can hold off on that.
Okay.
If you want to just go back to the board.
I will share
a
screenshot. I will share a screenshot in there. So in Discord. Great. So no problem. And yeah, I think that's the final thing. I added, like I said, this top level readme, so it's actually completed. I will just set in here this one that is the revision of all the PRs. So doing that, I think that I will close this and create this deployment in the CDN. And up to there, I think that will be like frozen after that, because I was working in the Polkadot apps actually.
Okay, and which CDN, or how are we going to deploy that over a CDN? Have you figured that out yet?
I'm going to use just the DigitalOcean CDN. It's really easy. It's all in there to actually to keep all the deployments in DigitalOcean or in the same provider actually.
Do they have does that mean we have to run a droplet for that, or is it we just upload it to their service like as a file system?
I think that you just have to create a space in there and just upload. It's pretty simple.
Okay, cool.
Creates some kind of
You guys hear Leo?
Yeah, it creates some
Yeah, we're losing you, Leo.
a stream bucket actually.
Okay. Leo, you might want to turn your video off. You're coming in really choppy.
I don't know what's happening actually.
Okay. So basically, you can just deploy it over there, CDN. We don't have to run anything special. That's great. Okay.
Yeah, it creates, there is a, call it spaces, DigitalOcean spaces, and it's run like some kind of S3 buckets and everything like in the feature itself. We don't need to create a virtual machine or a droplet, like nothing.
Okay, cool. So let's set that up as a relayer .subspace.network as a URL, and just if we need to coordinate with Justin or Diana to get that mapped in with Cloudflare, or maybe you can do that on your own, and then Diana can link that in the new version of the website that we're working on.
I got access to Cloudflare actually, I can create it.
Okay, just make sure Diana's aware of that as well. And Justin, since Justin is going to be having a status page for this relayer as part of our overall status page.
Okay.
Cool. Great. Sounds good, Leo. So in terms of all the stuff that Serge and I just reviewed in terms of the upgrades to support like not just relaying the current blocks, but storing the full history, do you expect that's going to require any changes to the front end, or should it just work as is, even as the back end gets updated?
I don't think that will be necessary actually, because it's the same data in the same format. So if we got one event or n events, it should be the same.
Okay, that's what I thought too. Just wanted to make sure. Okay, cool. Any questions for Leo or comments from the group? Okay, anything else we need to discuss? Okay, thanks a lot, everybody, for joining today. We'll see you again next week.